Hello, my friend. Today we will discuss about the carcinogenesis. So it means how a normal cell turn into the cancer cell. So what is carcinogenesis? Carcino related to means the process of producing cancer cell. As you look at the word and you will see carcino. Carcino means related to or refer to cancer. Related to cancer. And what is genesis? Genesis means give birth. So it means the process of giving birth the cancer cell. So to talk about carcinogenesis, so let me give you example of the comparison between the normal cell and malignant cell. We can also call malignant. We have normal cell and malignant cell. So malignant cell is a cancer cell and we have normal cell. So let's take example how a normal cell turn into malignant cell. Okay, now we will take for example, let's suppose I have a piece of skin here. I have a piece of normal skin here. So this is the piece of a normal skin. I will write out here normal skin. And then here I have a piece of what? Malignant cell, cancer cell. Yeah. Let's suppose this is a tumor, malignant tumor. Okay. Then how this normal cell turn into this tumor or malignant cell? And then first you must understand that how normal cell is working. So normal cell is working very strictly. So it means, for example, if you have an injury on the skin, for example here, if you have injury here, if you have the injury on the piece of the skin here, injury here. So to fix this, this injury, so the cell need to proliferate. It means the cell need to grow the new cell to fix this portion. This portion is injury. And now the cell start to proliferate. The cell will start to proliferate or grow. Okay, grow to fix this portion. So when they start to proliferate or grow in the cell here, so when this portion, when the cell receive the signal for proliferation, and then they start to grow and to fix this portion, and then they work very strictly. So it means they will not automatically proliferate when they don't receive any signal from the body. So again, let me explain again. Here you have the injury in the piece of the skin here. Okay, and then to fix this injury, so the cell need to start to grow new cell to fix this portion. Clear? But how? First, this cell need to receive the signal from the body, and then they start to proliferate it. Okay, but if they don't receive any signal from the body, they will not start to work. They will not start to proliferate. They will not start to make the new cell. No. Okay, but let's compare with the cancer cell. The cancer cell is autonomous. They have ability to grow by itself, to proliferate by itself. They don't obey the body. They don't need any signal from the body to start to proliferate. Okay, so that is the characteristics of the cancer cell. Now let's suppose here. Let me draw the normal cell. You will understand. Here For example, here I have a normal cell. So on this normal cell, we have the sets of gene. We have the sets of gene, three sets of gene. Of course, they have a lot of sets of gene, but I just draw here only three sets of gene. This is number one, and another set of gene. This is number two, and another set of gene. Here, number three. So the name of this first set of gene we call proto-oncogene. This proto-oncogene. Okay, and this is the DNA. This gene is responsible or has a duty for DNA replication. DNA replication. And this gene is name is tumor suppressor gene. Tumor suppressor genes. I will explain one by one. Okay. So this is the normal cell. Again, for example, here on your skin, you have an injury here. There. I should draw like this. Okay, you have injury here. So to fix this injury, now what the cell will receive a signal from the body. The body will send a signal. The body will send a signal for what? For proliferation. Proliferation means growing the new cell. Start to grow the new cell. Clear? So this signal from the body will send to this proto-oncogene. So this gene will release a factor. It will release a factor, and this factor will stimulate the DNA replication. It stimulates this set of gene for proliferation, means to copy the DNA. Okay, and means replicate the DNA. So means DNA replication happen through this gene, and the cell to start to make the new cell. Clear? And when they fix, for example, when they already fix this portion, and they need to be stopped. Okay, they need to be stopped. And how they stop? We have another set of gene here, tumor suppressing gene, and then this gene will send a signal to these genes to stop the DNA replication. Okay, so the work has done. Now the work has done because they already fixed this portion. Okay, so they work very, very strictly. They obey the law of the body. Means if this gene proto-oncogene, they don't receive any signal from the body, they will not work. Clear? But by cancer cell or malignant cell, the cancer cell, they have ability to promote or to send the signal or to release the factor to stimulate the DNA replication. How they can do that? Because this gene, they don't need any signal. They don't obey any signal from the body. And how they have that ability? How they have that characteristics? How? Because they change the genetic program of these genes. They change the genetic program of these genes, proto-oncogenes. So it means these genes are mutated. What happened? On the cancer cell, these genes are mutated. Mutated. So what is mutated? Or what is mutation? Mutation means genes already changed the program. Clear? Then, for example, and they have ability to send to another cell or to transfer to another cell. Means this genes is, for example, this is a set of gene. Okay, this is a set of gene, and these genes are mutated, and they have ability to send to another cell or to transfer to the new cell or to the daughter cell. This is the original cell, and then of the malignant cell or cancer cell. Clear? And they have ability to transfer to daughter cell. This cell we call daughter cell. We call daughter cell. So it means they are autonomous. How? They are autonomous means they already changed the genetic program here, and they have ability to promote, to stimulate this gene DNA replication, to continue to proliferate, to grow the new cell, and never stop this process. Okay. And second, they don't obey. So for malignant cell, they don't obey the signal. This we call you can call this tumor suppressor gene is a inhibitory gene. What? Inhibitory gene. So here you can say the genes stimulate the DNA replication. We can call this accelerating genes. So what does it mean? So let's take example. Let's suppose here you have a car. Here you have a car. Okay, here you have a car. So for example, this car is running on the highway. Okay, they are running on the highway. So when you want to increase the speed of the car, you have one mechanism, and this mechanism we call accelerator. So accelerator is a mechanism to increase the speed of the car. Okay, when you push the accelerator, what happens? The car will increase the speed. Okay, and then when you reach the speed that you need, and then what happens? Then you want to reduce the speed. Okay, decrease or reduce the speed, and then you have another mechanism. This we call brake. What we call brakes. When you push the brake, what happens? The car will reduce the speed. Clear? So the same. For example, now this is the normal car. The normal car, this mechanism is working very well. It's working properly. The same. This accelerating genes, the same as the accelerator of the car. And this inhibitory genes, okay, the same as the brake of the car. So when this proton coaching accelerating genes, when they promote this DNA replication, and what happened? And then when they reach to, are they enough, and the work has been done, and what happened? And then this genes, inhibitory gene, will inhibit the DNA replication. It means stop the work here. But what happens? Same. For example, this guy is you can say the malignant car. Malignant car means a malignant cell, or you can say the cancer car. The cancer car means now you start. Okay, they have ability to increasing the speed. So, for example, this mechanism is broken. And then automatically you don't push the accelerator, but the car automatically increase the speed. Okay, and you cannot do anything. You cannot do anything with this accelerator. And then you try to stop the car. When you try to stop the car, then you push the brake, but the brake is also it doesn't work here. So it means the car continue to increase the speed, and the brake is broken. Clear? The same here. Cancerous or cancer cell or malignant cell, these genes continue to increase the speed of the DNA replication. Clear? They will send the signal or factor to increase the speed of the DNA replication. It means Now you see, this is the normal skin. And here, what happened? The melanin cell start from here, from one cell, and then second cell, next cell, daughter cell appear, next cell, next cell. You see? And then they never stop. They never stop proliferation like this. Continue to grow like this. So this cell we call melanin cell. Okay? And when a lot of cell deposit here, and what happened? This cell become a mass, and this mass we call tumor, and this tumor is a malignant tumor. Okay, malignant tumor, and it's become very dangerous. The same for if you cannot stop this car and the brake is broken, and you cannot stop the accelerator, and this accelerator don't obey you also, and you are the body. Okay, you send the signal that you push it, you push the accelerator, but they don't obey. They just increase the speed like that, and you cannot do anything. You can then this car become very, very, very dangerous car. This can kill many people if the car is running in the city, and this car can kill many people. Okay, the same for the melanin cell. The melanin cell, this proto-onco genes continue to promote the DNA replication, and they don't stop. And these tumor suppressor genes, inhibitory genes, they cannot stop this DNA replication. And what happened? The cell, cancerous cells, malignant cell continue to increase the speed also, continue to grow also. And one day it will burst. Okay? It will burst, and then means you will die. So it means this cell now it means now become very dangerous tumor. Okay, now you understand what is the difference between the normal cell and malignant cell or cancer cell. Okay, now these genes, proto-onco gene, already mutated. They are already mutated. It's been already changed the genetic program. Now proto-onco gene will turn into oncogene. Okay. Now if in your cell, this set of gene, proto-onco gene, now will turn into oncogenes, and this gene what we call mutated genes, and this mutated gene is a cancer. You can say the genes of the cancer cell. Clear or not? The gene of the cancer cell. So this is the very basics, fundamental, and the difference between the malignant cell and the normal cell. Okay, in the next video, I will continue to share with you the how. Okay, we have another set of genes also. Before the normal cell reach to the malignant cell, they need a very, very long process. It cannot be simple like just by simple process they can turn normal cell into cancer cell. No, not like that. We also have another set of genes to fix if, for example, this tumor suppressor genes cannot work, cannot inhibit the DNA replication. So all these gene proto-onco genes are damaged. Okay, and what happened? We have another set of genes will fix this damaged genes. So every day in our body there are thousands of genes are fixed or thousands of genes are damaged, and we have another set of tool, okay, or mechanism to fix this. If we cannot fix this, and we also have another set of genes will be kill this gene, but that we will talk about in the next video. So thank you so much.